Welcome to the General Chemistry 2 class. This section is on chemical kinetics. This lesson is about the rate law. And now, let's begin. In this lesson, we will write the mathematical relationship between the rate of reaction, rate constant, and concentration of the reactants. For a reaction A forming B, the rate of equation is directly proportional to the power of the molar concentration of A. It implies that the reaction takes place at a higher rate when the reactant concentration is higher. The mathematical statement that shows the relationship between the rate of reaction and the concentration of the reactant is called the rate law. Rate equals K times molar concentration of A raised to the exponent n. The exponent n is the order of the reaction. The proportionality constant K is called the rate constant. For any reaction with more than one reactant, the corresponding rate law is given by the rate equals K times the molar concentration of P raised to the exponent x times the molar concentration of Q raised to the exponent y. The exponent x is the reaction order with respect to P, and the exponent y is the reaction order with respect to Q. The overall reaction order is the sum of the exponents of the reactant's concentrations, that is x plus y for the given reaction. The reaction order is usually whole number, 0, 1, 2, 3, and so on. Fractional orders are observed in some reactions. It is determined experimentally and is not based on the reactant's stoichiometric coefficients. Consider the reaction given by 2 moles of nitrogen dioxide produces 1 mole of dinitrogen tetroxide. Experiment shows that the reaction is of order 2. Write the rate law for the reaction. Nitrogen dioxide is the sole reactant in the reaction. The order 2 must be the exponent for the molar concentration of nitrogen dioxide in the rate law. Thus, the rate law is given by the rate equals K times the molar concentration of nitrogen dioxide raised to the exponent 2. Example 2. Consider the reaction of 2 moles iodide plus 1 mole hydrogen peroxide plus 2 moles hydrogen ion yielding 1 mole iodine plus 2 moles water. If the reaction is found to have an overall order of 2, with order 1 with respect to iodide and 1 with respect to hydrogen peroxide, what is the rate law for the reaction? The reaction is order 1 with respect to iodide and 1 with respect to hydrogen peroxide. Since the overall order is 2, it implies that the reaction has 0 order with respect to hydrogen ion. The reaction is not affected by varying hydrogen ion concentration. Thus, the reaction is given by the rate equals K times the molar concentration of iodide raised to 1 times the molar concentration of hydrogen peroxide raised to 1 times the molar concentration of hydrogen ion raised to 0, or simply rate equals K times the molar concentration of iodide times the molar concentration of hydrogen peroxide. To summarize, a rate law is an equation that relates the rate of reaction to a power of reactant's molar concentration. This equation reveals the rate constant and the reaction order. So here are the reference or bibliography of the lesson. Thank you. Welcome to the General Chemistry 2 class. This quiz is about the rate law. Let's begin. Number 1. The value K in the rate law is called the blank. Select the correct answer. A. Order, B. Rate constant, C. Molar concentration, or D. Rate. Number 2. The exponent of the molar concentration of a reactant in the rate law is called the blank. Select the correct answer. Number 3. What is the order with respect to the reactant if its concentration does not affect the rate of reaction? Select the correct answer. What is the rate law for the reaction S yielding products if the order of the reaction is 3? Select the correct answer. Number 5. Given a rate law, rate equals K times the molar concentration of T squared times the molar concentration of U times the molar concentration of V. What is the overall order of the reaction? Select the correct answer.